this is joint work with Greg Lewis from Microsoft Research and Giorgos Zervas from Boston University. So a first step in understanding market structure is understanding consumer demand. But approximating demand in a market often requires a simplifying assumption for feasibility, such as projecting products into a low-dimensional characteristic space. But what happens when characteristic data is insufficient, when preference heterogeneity is substantial and very difficult to model? For example, sometimes we have good characteristics for products in our market, such as the horsepower of cars, but there are others that still might be really important for how consumers choose vehicles that are less measurable, such as the style of a car. So the first question we're going to try to answer is, can we learn better characteristics and preferences? And our answer is going to be yes. Using machine learning techniques off the shelf, specifically the Stefan Rendell paper from 2009, we're going to learn latent preferences and characteristics of products, hotels in our case, from search data. And then we're going to ask whether we can use these characteristics to improve demand estimation. And we're going to show that these latent characteristics capture substitution patterns from entry events and lead to a 15% improvement in predicting demand over existing demand models, such as the canonical BLP model in industrial organization. So the data we're going to use, we're going to study the market for hotels in 5 Western states, and we're going to have the standard aggregate market level data that one would use when trying to estimate demand in a market, specifically a monthly panel of prices and how many rooms are sold at each hotel from STR. And we're going to pair this with some observable characteristics of these hotels, such as where they're located, what year they open, how big they are, and an ID that's uniquely associated with each hotel chain or brand. And then what we're going to do is complement this with some auxiliary search microdata. Specifically, we're going to use a sample of 18,500 Expedia users in 2014-15 that were searching for hotels in our sample. So specifically, we're going to observe for each user a unique ID identifying a single browsing session where they're sitting in front of the computer for a continuous amount of time. And then we're going to also be able to observe each hotel ID that was viewed on these Expedia web pages during their search session. So before I describe the model that we use, let me tell you at a high level about what we're trying to do in this paper. So typically, discrete choice is identified off of a single purchase decision. Since you only have you have unit demand, you only show up to the market to buy one item. And in contrast, with search, consumers reveal preferences for multiple items, since they'll search for multiple things, even though they're only going to buy one. So specifically, if you suppose hotels A and B are commonly searched together despite having divergent observable characteristics, this is the fact that they're being searched together and there's unit demand implies that these hotels are substitute. And so that must mean that they have some common unobservable characteristics. And so we're going to use this intuition to better identify these unobservable characteristics. And the last thing I would say is this is related to a literature on second choice data that has been used in demand estimation before and has been shown to be a substantial improvement in terms of measuring substitution patterns in the past. So we view this as an extension of that prior work. Okay, so now I'm going to tell you a little bit about the model. So consumers are going to have unit demand, as I said, and they're going to have heterogeneous linear preferences over some characteristics. They're going to have heterogeneous preferences over prices, and they're going to have homogeneous preferences over a demand shock. And we're going to assume that this vector of characteristics can include characteristics that are both observable and unobservable from the perspective of the researcher, but observable to consumers at the time that they're making a search decision. And we'll denote these unobservable characteristics by gamma. So we're going to also assume that the number of products is large in this market, and consumers don't know the demand shock ex ante, so they have to search for products. Specifically for tractability purposes, we're going to assume that they engage in non-sequential search to form their consideration set, and that's going to basically boil down their search problem into just maximizing expected utility in linear way, in linear complexity, I should say. So specifically, we're going to learn 3 versions of this model, and all of them are going to have latent search preferences. one with only observable characteristics, one with only unobservable latent characteristics. So that means we're not using any of the observable characteristics data that we receive from STR, and then one that combines both. And we're going to specify beta I, alpha I, and gamma J non-parametrically, meaning for each consumer, we're going to learn a unique vector of their preferences, and similarly for each hotel. And this is a large number of parameters to learn in our most complex model, which is the third one. This is going to imply about 370,000 parameters we need to learn. So this seems like kind of an infeasible problem, but we're going to basically rely on some machine learning methods that have been used with great success in the last 2 decades to learn basically a vector representation of products and consumers from their search behavior, specifically their click data, since we're going to interpret when a consumer clicks on a hotel as them searching. Okay. So let me describe the algorithm in a little more detail and how we're using it to successfully back out these latent preferences and characteristics. So we're going to estimate these parameters using an algorithm known as Bayesian personalized ranking. And basically, this is going to use pairwise combinations of products in the market and what a consumer's revealed preferences are about these products to learn the latent embeddings. Specifically, if you consider a product J that's in consumer's consideration set and a product K that's outside of the consumer's consideration set, so they search for J and not K, then according to our search model, this is going to imply that the expected utility from J is higher than the expected utility from K. And we're going to basically combine all these pairwise inequalities to form a likelihood. And in fact, the number of inequalities that we get is going to be proportional to the size of each individual's choice set. And in our example, we're going to have on average about 10,000 of these inequalities per consumer, which greatly alleviates this previously intractable problem of trying to estimate a unique preference parameter for each consumer, since we have roughly 10,000 data points for each consumer. Okay, so that at a high level describes the model. And now I'm going to talk about some of the empirical evidence we offer to show that this model is doing a good job to recover things that we think are important for demand estimation. So here on the left panel, I have the spatial distribution of hotels in our sample, color-coded by the market they belong to according to our data provider's market definition. And then on the right panel, we have a 2-dimensional projection of the model that was run using only latent characteristics. So that means it only used search data. It didn't use any of the data provided from our hotel observables data set. So that's projected onto a 2-dimensional space. And what we can see here is, despite the fact that we're only using consumer search data to generate this plot, clusters form that roughly correspond to the market definitions that STR provided us. And so this suggests that these search embeddings that we estimate are able to successfully recover some notion of hotels being close in characteristics. Specifically, in this case, the hotels that are close in the latent characteristic space appear to be close spatially, which we know is an important input into how consumers choose hotels. Next, I'm going to describe our next piece of evidence. So we're going to now evaluate the quality of these embeddings that we recovered from search data by assessing the effects of a hotel being close in the characteristic space to a new entering hotel. And the intuition for this exercise is going to be that incumbent hotels, when a new product enters or a new hotel enters, the incumbent hotels that are most similar in characteristics to the new hotel should experience more substitution away from them, and so should be more hurt by the new entry. So specifically what we're going to do is we're going to construct 3 different distance metrics between an incumbent hotel and a new entrant. The geographical distance, which captures pure spatial differences, a aggregate Mahalanobis measure of distance on all the observables that we obtain from STR, and finally a Euclidean distance that's based solely on the latent characteristics that we recovered from search data. And we're going to use this metric to estimate an event study where we're going to regress demand, or the number of rooms sold, on a hotel by event fixed effect with with time fixed effects, and then an indicator for a hotel being close in the characteristic space to the entrant times a time dump relative to the period that the hotel entered, which is, and the period is a month. And we're just gonna, for simplicity of interpretation, we're gonna define a hotel being close to an entrant as being less than the 10th percentile among all the incumbents that are affected by this entry. So here we have our estimates of these event studies. So I'm going to start with the green lines or the green dots. This is the distance metric from all the observables in our data. And we see that being close in observables, at least by the metric we constructed, doesn't seem to have a significant effect after the hotel enters, which is marked by period 0. However, when we use our characteristic space that was based only on search data, we find a 1% decrease in demand relative to all other hotels in the same market for those hotels that are closer to the entering hotel. And then finally, in the red, we show that actually using only geographical distance leads to an even stronger effect. And so what this suggests to us is that our search metric is able to accurately capture some substitution patterns in the sense that hotels that are closer in that space experience a larger decrease in demand, but it's still imperfect and still unable to replicate the effects of a product attribute that we know matters quite a bit, which is the spatial distance between hotels. Okay. And then next, I'm going to present to you our final piece of evidence. It's going to be a merger case study. So one objective of demand models in economics, one of the reasons we estimate these models is that we want to be able to correctly predict changes in demand due to a change in market structure or some sort of counterfactual policy. So as a case study, we're going to use Marriott's acquisition of Starwood Hotels, which occurred in September 2016 and led to Marriott becoming the largest hotel chain in the world. So this was a very significant merger. And in fact, we show via another event study in the appendix that in areas with a high concentration of these hotels, prices change substantially relative to hotels in other markets where there was not so much concentration. And specifically, what are we going to do? We're going to train a discrete choice demand model on pre-merger market level price and quantity data, and then evaluate that model's fit on the held out post-merger data to see to what extent the different models we choose, which I'll present on the next slide, are able to accurately predict what happened after this large merger that led to large price changes. Okay. So our task is going to be, the task that we're going to set out to do is to forecast annual demand post-merger, as I just said, and we're going to evaluate the fit of 3 discrete choice models for this presentation. The first is going to be a standard logit model, which basically assumes no consumer heterogeneity. The second is going to be a workhorse demand model in industrial organization known as BLP, which basically allows for random heterogeneity by consumers, specifically normally distributed heterogeneity, along the observable attributes of hotels. So they're allowed to randomly like or dislike where a hotel is located or the size of the hotel, for example. And then next is going to be the same BLP model, but instead of just using observable attributes, we're going to also add these 5 learned search attributes that we got from one of our versions of our search model. And then instead of drawing from a random distribution of a normal distribution of preferences, we're going to plug in the empirical distribution of the estimated search preferences we recovered from the Expedia data. And in all these models, we're going to include hotel fixed effects. And because there's no time variance in the attributes of hotels in our data set, this is going to basically make sure that all of our models accurately predict the level of demand across hotels in our data set. But the only difference is going to be on how they're measuring preference heterogeneity. So here's what the results look like. On the bar chart shows the out of sample mean squared error in terms of predicting log demand post merger. So this is This is you train the model on the pre-period, pre-merger data, and then see how well it fits this post-merger data that it didn't see while during training. And we see that in general, the logit model does not perform very well. And actually, because we have relatively good observable characteristics data, the BLP model that includes these with random heterogeneity performs fairly well. It's about 39% better than the logit model. But then when we include our latent characteristics and preferences, we experience a 15% improvement in at least mean squared error in terms of predicting post-merger data. So to conclude, we saw that we showed in this paper that latent attributes that we recover from search data do contain some informative content. They're able to predict demand patterns that we would expect after the entry of new firms, and they outperform the existing demand estimation machinery after a large merger occurred in our data set. Our analysis suggests that these latent characteristics we recovered may be probably even more useful in settings where rich observables are unavailable. For example, thinking about the market for books, it's very hard to characterize with in a low dimensional characteristic space which books are substitutes to one another. And finally, if I could leave you with the key takeaway, our takeaway from this project has been that by plugging in information from search data into even a traditional demand model, even when that search data is only one platform within a greater market, we're actually able to forecast substitutions patterns better when trying to characterize what happens in an entire market after a large change in market structure. So thanks for listening, and look forward to comments.